So the first topic, this video is on the first topic on simplifying rational expression. So the big idea to keep in mind is that when you're simplifying rational expressions, or adding, subtracting, or multiplying, dividing, they follow the same rules pretty much when you're working with fractions. So in terms of simplifying fraction, if say you had, a simple problem like 3/6 and you're being asked to reduce it, most people just say automatically that it's 1/2. And the reason why it's 1/2 is because um, 3 times 1, 3 can be written out as 3 times 1, and 6 can be written as 3 times 2. And so when you guys usually simplify this, you always say, well, I could divide the numerator and denominator by 3, and then you get the 1/2. And the reason why you picked the 3, you divide by 3, because 3 is a common factor of itself and a common factor of 6. So that's why 3 is picked, because 3 is a common factor of 3 and 6. So using like a different example, like if you had like 12 over 4. So we know the answer is 3, but if we kind of slow down the process, you guys would say, I would divide the top and bottom by 3, and then you'll get 4 over 1. Oops, nope, the common factor would be 4. And you would say that it's 3 over 1. Well, why do we divide by 4? We divide by 4 because 12 could be written as 4 times 3, and 4 can be written as 4 times 1, and 4 is what's called a greatest common factor. What's called a greatest common factor of 12 and 4. So when we're gonna do the examples of rational expression, we're gonna kind of follow the same rules, where we're just kind of break down the numerator and the denominator into its factors, and then we want to break into factors where one of the factor is the greatest common factor. That way we can divide it out. Okay, so for simplifying rational expression, there are 3 main steps. The first thing is you want to factor the numerator if it applies. So there are going to be 2 different methods they're going to be using for factoring. The first one's factoring out the greatest common factor, which is like this one, when we are identifying what the greatest common factor of these 2's are. And then 2, there's factoring using the box method. So a little comment about factoring using the box method. You may have learned other methods for factoring, so you could definitely use that if you find it easier. Step 2 is to also factor the denominator, and then step 3 is canceling out the common factor in the numerator and denominator. Okay, so let's take a look at the first example. So the first example is specifically on simplifying with factoring out the GCF. So this is the rational expression, and so the very first step is I want to factor the numerator. So I want to take a look at the numerator here, which is 4x squared minus 4x, and I'm going to pay attention to what the common factors are here. So another way of thinking about common factors, like I want to think about what is the largest number I can divide out of the number parts and also the variable parts. So if I'm looking at just the 4 here, the largest number I can think of that divides both 4 and 4 is itself 4. So what I can do is I'm going to factor out a 4, and then I'm looking at the variable part. So this has x squared and this has x. So the greatest common factor or greatest common divisor here is x. So I'm going to rewrite this as 4x. So this is called the greatest common factor. Both terms have a common factor of 4, and both terms have a common factor of x. So this is greatest common factor. After you take out the greatest common factor, then you want to think about, well, 4x times what will give me x? Well, 4x times x is going to give me the 4x squared. And then 4x times 1 gives us times negative 1 gives us the negative of 4x. So it's just a quick check of how this process works. I'm just going to distribute. So 4x times x is 4x squared, and 4x times negative 1 gives me negative 4x. So this is the factored form of the numerator. And I'm going to repeat the same thing to the denominator, so 6x minus 20. And again, I'm going to look at the number parts, 6 and 20, and try to think of the largest number that divides both 6 and 20. So 6 and 20 are even. I think of 2 first off and see if there's any other number larger than 2 that divides both 6 and 20. And I can't think of any other one. Therefore, the greatest common factor of 6 and 20 is 2. And then I'm looking at the variable part. So the first term has x. This one doesn't have a variable part, so it doesn't have a greatest common factor for the variable part. Therefore, this greatest common factor is just 2. So now I need to think of a 2 times what gives me 6x. That's going to be 3x. And then 2 times what gives me negative 20. That gives me negative 10. Another way to think about getting these values is just dividing both of these by 2. So 6x divided by 2 is going to be 3x. And then negative 20 divided by 2 is going to give me negative 10. So you can think of in terms of division, or you can think of in terms of multiplication. So that's step 1. Step 2, I factored. And now I want to write each of those results on top of each other. So 4x minus times x minus 1 divided by 2 times 3x minus 10. And now here's the part where you cancel out. So I'm going to look from numerator and denominator and try to reduce as much as possible. So I see 4 divided by 2 here, so that can be divided into 2. And then x, there's no x in the denominator, so that x has to stick around. And then I see a factor of x minus 1 and factor of 3x minus 10. Those two aren't the same, so they have to stay where they are. So it'll be x minus 1 over 3x minus 10. So therefore, the simplification of this original expression is this.